Imagine peering through a telescope at the edge of our solar system, seeing nothing but darkness and scattered points of distant light. Yet, suspecting, against all odds, that an invisible planet hides out there, tugging at Uranus with its unseen gravitational hand. How could you prove a hidden world exists when no one has ever seen it? And what happens when the search for that world launches two rival teams, working in complete secrecy, racing to claim the discovery of Neptune? For centuries, the classical planets, Mercury, Venus, Mars, Jupiter, Saturn, were the only ones visible to the naked eye. Then came the invention of the telescope, opening up new mysteries. Astronomers discovered Uranus in 1781, shattering the ancient idea that Saturn marked the outer boundary of our solar system. But Uranus brought with it a puzzle, one that would set off a chain of logic, suspicion, rivalry, and discovery that reads almost like a science fiction detective story. Let's start with the Anomaly. After Uranus entered the books as the seventh planet, astronomers set about charting its orbit carefully. Over the years, they realized its path wasn't behaving as Newton's laws predicted. Uranus sped up and slowed down, sometimes drifting away from the mathematical track it was supposed to follow. Was Newton wrong, or was something else pulling Uranus out of line? This is where the power of mathematical imagination comes in. Two men, one in England, one in France, decided to flip the script. Instead of seeing Uranus's irregularities as a problem, they treated them as a clue. What if the source of the pull was another planet, one nobody had seen yet? Let's look at how bold that idea really was. Imagine you're told a planet exists because the math says so. We just have to find it. There's no physical evidence, no blurry telescope images, just pure calculation. In England, the mathematician John Couch Adams began working on the puzzle in secret. He pored over tables of Uranus's motions, measuring every deviation, every mysterious tug. Through tireless computation, he tried to calculate where the perturbing planet might be, hoping to predict its location before anyone actually saw it. Meanwhile, in France, Urbain Le Verrier turned his sharp mind to the same problem, using a totally independent method, without ever knowing what Adams was doing. This kind of parallel discovery is rare in science, but electrifying when it happens. Both men, separated by geography and language, worked through long nights crunching numbers that represented real forces a billion miles away. The math was remarkably complex. Calculations that filled dense pages with equations, trying to reverse engineer not just the existence, but the actual position of the invisible Neptune. Le Verrier finished first. He wrote to the Berlin Observatory, urging the astronomers there to turn their telescopes to a very specific patch of sky. On September 23, 1846, Johann Galle received Le Verrier's letter and checked the suggested area against a star chart. That very night, Galle and his student Heinrich Derrist found a bright star in the right spot, one that wasn't on the charts. Night after night, they saw it move. Let that sink in. Neptune was discovered within a single degree of the position Le Verrier predicted. By math, not by sight. This was the birth of a new kind of astronomy. The universe was suddenly not just what we could see, but what we could infer from the precise dance of gravity. The discovery proved that mathematics could reach out across empty space and find something tangible, something real. But the discovery was not without controversy. In England, Adams's supporters insisted he'd solved the riddle first. But communication delays, hesitance, and a lack of forcefulness with the astronomers at the Royal Observatory meant that the English astronomers didn't turn their telescopes in time. The French, meanwhile, claimed the glory. For months, scientific Europe was caught in an argument about who deserved the credit. This episode didn't just reveal Neptune. It revealed the delicate human element in scientific discovery. Ambition, rivalry, persistence, and also the happenstance of timing. Two brilliant minds could race to the same solution, but the story of who gets remembered depends as much on letters sent and nights lost in calculation as on the mathematics itself. Now, let's pause to reflect on the deeper meaning behind this drama. The Search for Neptune is a powerful story about trusting evidence that can't be seen. It's about believing in the reality of something offered up by reason, even when physical proof is missing. In philosophy, this is reminiscent of the idea that the true mark of understanding isn't always direct observation, but sometimes the clarity of the reasoning that leads inevitably to the truth. Sometimes we see by logic and only later confirm with our eyes. It's also a story about the limits and powers of prediction. Neptune was found not by accident, but by deduction. The laws of gravity and motion were so well understood that they could be run in reverse. Use the effect to find the cause. It is one of the earliest examples of what's sometimes called physics in the blind, making a leap of faith into the unseen, guided only by the reliability of natural law. But this discovery also raises questions about the nature of credit, competition, and recognition in science. Adams and Verrier both arrived at the correct answer, but history remembered Verrier because his prediction was acted on first. How much of discovery is insight, and how much is timing? How much depends on persistence, and how much on luck? Every great breakthrough carries a human backstory, sometimes exhilarating, sometimes painful. The boundary between the known and the unknown never stands still. The discovery of Neptune marked a moment when humanity's conceptual reach extended far beyond what could be plainly seen. The solar system grew overnight, without a new voyage, but with the power of intellectual exploration. The universe became more mysterious, but also more accessible to the curious mind. Now, consider this passage. All things are full of gods. That phrase echoes from ancient Greek philosophy, a way of saying that the universe is charged with meaning, that even what seems empty hides forces waiting to be discovered. The search for Neptune is proof. Hidden worlds can be brought into view when we look beyond appearances and trust the patterns. The second reflection is about humility. For all our pride and prediction, the universe always keeps secrets waiting. Neptune, as it turned out, was not quite where Newtonian mechanics first pointed. There were later corrections and even deeper mysteries, as when Pluto was found and then demoted. Science moves forward in steps, sometimes stumbling, always revising. And yet, what a testimony to our ability to reason beyond our immediate senses. To look at a distant world's effect on another's path, and from that minuscule hint, to imagine a new planet, and then to find it exactly where reason predicted. This is exploration in its most elegant form. When Neptune was finally seen, it was a blue dot in the sky, barely distinguishable from the background stars. But its discovery was a beacon, a way of saying the universe is readable. Its secrets are there for the bold. Let's revisit the lessons this story offers today. First, that curiosity is more than just wonder. It's a process, a method, and sometimes a competition. The scientists who chased Neptune looked beyond the obvious, asking not just, what is there, but what must there be? They were willing to follow the logic wherever it led, changing astronomy forever. Second, the interplay of sight and insight. The math came first, and only later the observation. In many ways, this mirrors the relationship between theory and experiment in all of science. Theories dare to go further than evidence, but observations reel them back, or sometimes launch them further than anyone had guessed. Third, the story reminds us that recognition in science often owes as much to human quirks, timing, communication, politics, as to the brilliance of the ideas themselves. Progress is human, and that means it comes with all our strengths and foibles. And finally, perhaps the most exhilarating idea, that the universe does not depend on our awareness to exist. Neptune pulled at Uranus long before anyone had a name for either one. The dance of the planets continued patiently, for eons, waiting for us to notice, to ask questions, and finally, to understand. The search for Neptune is not just an episode in the history of astronomy. It's a reminder that the vast universe is out there, shaping, nudging, pushing, even when unseen. It's an invitation to keep asking questions, to trust in the power of patterns, and to remember that there may always be another world waiting to be discovered by those willing to look beyond what they can see. All things are full of gods. Or, to put it in modern terms, every unexplained pattern could be a signpost pointing to something grander, more hidden and more wonderful, existing just beyond the edge of vision. So next time you look up at the night sky, remember, somewhere out there, the story of Neptune is still unfolding. Not as a static fact, but as a living proof of humanity's drive to understand the universe. Not just by seeing, but by daring to believe that even the unseen may one day come into the light.